The morning of February 12th, 1943, dawned grey and humid over Rabaul. The volcanic air smelled of oil, rust, and tropical decay. On the edge of the captured Allied supply depot, a small group of Japanese officers gathered around something they had never seen before. A squat, open-topped vehicle coated in dust and bullet scars. Its olive paint still bore the faint white star of the United States Army. Captain Masao Kitamura of the Imperial Japanese Army Engineering Bureau adjusted his cap and studied the strange machine. He was 32 years old, an engineer by training, a soldier by necessity. The war had carried him from Manchuria to New Guinea, but never before had he encountered an American vehicle intact enough to study. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The Jeep had been captured 3 days earlier near Buna after a chaotic skirmish in the lowlands. It had survived 2 grenade blasts, an engine fire, and 100 miles of jungle mud. Japanese soldiers, impressed by its sheer stubbornness, had pushed it onto a transport barge bound for Rabaul, the Imperial Navy's most fortified base in the South Pacific. Now, as Kitamura circled the vehicle with a notebook in hand, he could feel the same unease that had unsettled his German counterparts months earlier in North Africa. Something about this crude-looking American contraption defied every principle of engineering he had been taught at the Imperial University of Tokyo. It was ugly, he thought. Ungraceful. The welded seams were coarse, the paintwork crude, but the lines of stress, the geometry of the frame, the angle of the axles, the ratio between wheelbase and width, all suggested something far more deliberate. Lieutenant Tadao Hoshino, an automotive designer from the Tokyo Gas and Electric Works, knelt to inspect the undercarriage. He ran a finger across the transfer case, wiped off a layer of dried mud, and frowned. Rensha Shiki Yonkado, he murmured 4-wheel drive. Kitamura raised an eyebrow. Impossible, he said quietly. Not at this weight. For years, Imperial Japanese engineers had assumed that compact 4-wheel drive systems were impractical in light vehicles. Their own Type 95 Kurogane reconnaissance car, the pride of Japanese motor design, weighed almost the same as this captured Jeep, but featured only part-time drive to the front wheels through a complex linkage that required frequent adjustment. It could barely climb a 20-degree slope in wet conditions. This American vehicle, by contrast, had reportedly crossed flooded creeks and deep jungle mud under enemy fire, hauling a full load of ammunition at what soldiers claimed was nearly 60 miles per hour. That claim alone had drawn skepticism from Tokyo. 60 miles per hour off-road? Even heavy trucks bogged down at half that speed on the rough coral trails of the South Pacific. Yet the reports from the field were consistent. American Jeeps seemed to appear and disappear across impossible terrain, sometimes outpacing motorcycles, sometimes towing artillery through swamps where even pack mules had failed. Kitamura climbed into the driver's seat. The metal felt cool and utilitarian beneath his palms. The steering wheel was worn smooth. On the dashboard, a small plate bore the stamped words, Willys Overland Motors, Toledo, Ohio, USA. He turned to Hoshino. We'll disassemble it. Every part, every gear. The inspection order was signed that afternoon. By evening, the Jeep had been moved into the engineering hangar, placed on wooden blocks, and stripped piece by piece. Within 24 hours, the men had a rough diagram of the American machine. Its design philosophy baffled them. Unlike Japanese or German vehicles, which pursued precision through tight tolerances and specialized craftsmanship, the Jeep's genius lay in the opposite direction: durability through simplicity. The steel was not exceptional, yet the arrangement of its components produced strength out of proportion to its mass. The gearbox, a 3-speed unit coupled to a 2-range transfer case, could be repaired with basic hand tools. The cooling system, entirely conventional, resisted overheating even after hours of continuous testing. In his first report, Kitamura wrote, "The Americans have constructed a machine which functions in defiance of its own crudity. It should not work so well, yet it does." The simplicity of the mechanism renders it nearly immune to failure. This contradicts our teaching that reliability requires precision. That single observation captured the deeper irony of the Japanese wartime engineering mindset. Since the 1930s, the Imperial Army and Navy had developed their machines around artisanal craftsmanship, small batch production, expert assembly, and meticulous fit. A Type 0 fighter's engine might take weeks of hand adjustment. The naval torpedoes, known as long lances, represented the pinnacle of precision machining. This philosophy produced brilliance in limited quantities, but suffered from a crippling vulnerability. It could not scale. By 1943, Japan's entire automotive output, including all military vehicles, had barely exceeded 40,000 units. In the same year, the United States had built over 600,000 Jeeps alone. That ratio, 15-1, was more than a statistic. It was the measure of an empire's strategic blindness. Imperial propaganda had long portrayed the United States as a decadent machine culture, a nation whose abundance had eroded craftsmanship and spirit. In engineering schools from Osaka to Yokohama, professors lectured that American products relied on quantity over quality, standardization over genius. Even senior officers repeated these claims in training manuals. The captured Jeep sitting in the Rabaul hangar was therefore a quiet contradiction, a small, steel embodiment of an uncomfortable truth. The men studying it felt the weight of that irony. In one of his field diaries, preserved today in the National Institute for Defense Studies in Tokyo, Lieutenant Hoshino recorded his own impression. "We had believed American design to be primitive, yet this vehicle shows an intelligence different from ours. It is made not for perfection, but for endurance. It sacrifices elegance for function and thus achieves a kind of superiority we cannot easily admit." Outside the hangar, the island war dragged on. American bombers raided Rabaul almost nightly. Fuel convoys from Truk were being cut to ribbons by submarines. Replacement parts for Japanese aircraft were arriving months late, if at all. Mechanics were melting down aluminium scraps to repair engines. And yet, in the middle of that logistical ruin, a single American Jeep still ran perfectly after months of combat use, needing only fresh oil and fuel. Kitamura tested it himself on February 18th. The engineers cleared a rough track outside the depot, a mixture of sand, coral, and volcanic soil. They filled the tank with captured gasoline, checked the oil level, and set off. At first, the ride was unremarkable. The steering felt loose, the suspension stiff, but as the Jeep gained speed, Kitamura realized he was driving through terrain that would have broken the axles of most Japanese trucks. The small vehicle bounced and jolted but never faltered. He shifted into second, then third. The speedometer climbed past 40. The engine roared but remained steady. By the time he reached 55 miles per hour, the other officers were shouting for him to slow down. The tires sprayed volcanic dust behind him in a long, arcing plume. The vehicle skimmed over roots and roots like a motorized insect. When he finally cut the ignition, Kitamura sat, in silence for several seconds. His hands were trembling, not from fear, but from realization. He turned to Hoshino and said softly, "We have nothing like this." That night, he wrote in his diary, "Today I drove an American Jeep at speeds impossible for our own vehicles. The design is rough, but the performance astonishing. I must admit, they have built something beyond our expectation. The Americans have solved problems we believed unsolvable." In the following weeks, copies of the Jeep's technical diagrams were sent by submarine courier to the Army Technical Bureau in Tokyo. The analysis arrived too late to influence Japanese production. The war's industrial tide had already turned. But within the small circle of engineers who studied that report, the implications were profound. For the first time, they began to understand that the enemy's strength lay not only in numbers, but in a design philosophy born of democracy itself. The belief that machines should serve ordinary soldiers, not depend on their skill. That realization would haunt many of them long after the war's end. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, It means a lot to us. Now, back to the story. By late February of 1943, the testing ground outside Rabaul had become a small stage for an intellectual confrontation few of its participants would ever forget. The captured Jeep, identified from its serial plate as a Willys MB built in Toledo, Ohio, in late 1942, now stood beside two Japanese vehicles for comparison, a Type 95 Kurogane reconnaissance car and a Type 1 Hoki half-track. The Kurogane, introduced in 1937, had been the world's first mass-produced four-wheel drive vehicle. At least, that was how Japanese engineers described it in official literature. In truth, only about 4,000 were ever built, and fewer than half survived to see actual combat. Its tiny V-twin air-cooled engine produced just 36 horsepower. Empty, it weighed slightly over 2,800 pounds, leaving little power to spare when loaded with troops or gear. The Hoki half-track was heavier and mechanically more robust, but it required constant maintenance and consumed precious fuel at an alarming rate. Kitamura and his team arranged a series of controlled trials. Slope climbing, traction testing, load capacity, and endurance under heat stress. Every trial was recorded in notebooks and on a captured American film camera, whose reels would later vanish amid the chaos of the war's end. On March 1st, they began the first full comparative test. The course was a half-mile loop through broken volcanic terrain, rutted coral, fine ash, and steep grades that simulated jungle trails. The Kurogane went first. Its driver struggled to maintain momentum as the front wheels lost traction in deep sand. The little engine whined in protest. Halfway up the slope, the vehicle stalled, forcing the crew to push it free. Next came the Jeep. Kitamura climbed in, adjusted the choke, and released the clutch. The engine caught instantly with a low, even rumble. The vehicle moved forward with unhurried confidence. He shifted to four-wheel drive and low range as the grade steepened. The Jeep climbed the same slope without drama, its engine note steady, its tires digging confidently into the loose earth. At the summit, Hoshino timed the run with his stopwatch, 42 seconds faster than the Kurogane. By the second run, the result was undeniable. Even with a full load of supplies and 3 passengers, the Jeep outperformed the Japanese vehicles in every measurable category: acceleration, traction, endurance, and even fuel efficiency under stress. The officers gathered around it afterward in uneasy silence. The difference was not just one of power, it was philosophical. The Jeep's engineering had been guided by a completely different set of assumptions about what soldiers needed and how machines should behave in the field. Japanese design emphasized precision, but also hierarchy. Mechanics were expected to maintain machines meticulously, soldiers to treat them as instruments of discipline. American design assumed the opposite, that chaos, ignorance, and brute necessity would rule the battlefield. The Jeep was therefore built for abuse. When the American manual arrived with the captured vehicle, its contents provoked astonishment. The English diagrams showed simple maintenance procedures illustrated for the average soldier. The language was conversational, almost casual. Step-by-step instructions described how to repair a clutch or replace a differential with nothing but basic tools. Kitamura's interpreter translated one line aloud to the assembled engineers: "Any man with hands can keep this vehicle running." It was, for the Japanese officers, an almost subversive sentence. For years, Japanese doctrine had taught that technology required discipline and purity of spirit, that mechanical excellence was a reflection of moral character. Even maintenance was treated as a quasi-religious duty. Yet here was a machine that worked precisely because it expected failure and ignorance, and designed around them. The discovery disturbed them more than they cared to admit. Lieutenant Hoshino recorded in his notes, "The Americans have democratized engineering. They have made machines that forgive mistakes. We design machines that punish them." Each vehicle was to run continuously for 12 hours over alternating stretches of mud, gravel, and coral track, simulating jungle operations. By the 6th hour, the Kurogani's front axle seal had failed, leaking grease onto the brake drum. The Hoki's cooling system overheated twice. Mechanics worked frantically to keep them moving. The Jeep, however, ran without complaint. Its engine, temperature remained steady, its gearbox cool to the touch. The only maintenance required was the tightening of a loose fan belt and a change of spark plugs. At hour 12, the Jeep was still running at nearly full speed, an astonishing endurance that none of the observers had expected. One of the naval officers present, Commander Takasugi of the Kure Technical Division, turned to Kitamura and asked half-jokingly, "Do you think they have trained their machines to fight?" Kitamura only shook his head. "No," he said quietly, "they have trained their machines to survive." The next stage of testing focused on materials analysis. Samples of the Jeep's frame steel, axle shafts and suspension springs were removed and tested for hardness and tensile strength using improvised methods. The results again surprised them. The metal was not extraordinary mild carbon steel, inexpensive and easily produced, but its uniformity was remarkable. Every component, no matter how small, adhered to consistent dimensions. Japanese industry at that stage of the war could not match such consistency. Repeated bombings of steelworks at Yawata and Muroran had disrupted alloy production. Quality varied from batch to batch. Spare parts often required hand-fitting. The Jeep's parts, by contrast, were so standardized that components from different factories, even from different manufacturers, fit perfectly together. The men studying the Jeep realized that this standardization reflected a depth of industrial coordination beyond anything the empire possessed. American factories had unified their designs so completely that a Jeep built in Michigan could be repaired with parts made in California or Pennsylvania. To Kitamura, this was more frightening than the vehicle's speed. It meant that America's strength was not in the brilliance of individual engineers, but in the system that connected them. That spring, as Allied bombers intensified their raids, Kitamura's team completed their final report. It was written in measured technical language, but between the lines ran a quiet note of despair. The enemy vehicle, known as Willys MB, displays extraordinary durability under prolonged stress. Its power-to-weight ratio, traction, and thermal stability exceed the specifications of all current Imperial designs. Manufacture relies on high precision in mass production rather than individual craftsmanship. Recommend study of American industrial methods for future development. The report was sent by submarine to Tokyo in April of 1943. Whether it ever reached its destination remains uncertain. The sub, I-182, was lost on its return voyage near Truk Lagoon, likely sunk by an American destroyer. But copies of the field data survived in Rabaul, preserved by a handful of engineers who continued to maintain captured Allied vehicles for logistical use. As fuel shortages worsened, the Jeep became an unlikely symbol of practicality amid the Empire's collapsing infrastructure. By late 1944, when American carrier raids had rendered Rabaul effectively isolated, Kitamura's team was still using the same Jeep for transport within the base perimeter. Despite minimal maintenance and unfiltered fuel, it remained operational. The irony was not lost on them. One of the last surviving entries in Kitamura's wartime notebook reads, "Our aircraft rot on the ground for want of fuel. Our trucks break axles on coral roads. Yet this single American vehicle, built by men we called inferior, still carries our wounded to the hospital. I begin to think their strength is not in machines, but in the belief that all men deserve machines that work." He underlined the sentence twice. The engineers never saw the war's end together. In early 1945, Rabaul's garrison was cut off completely. Supplies ceased, morale withered, and most of the technical staff were reassigned to field labor. When Japan surrendered, in August, Kitamura and Hoshino were among the few survivors. In post-war years, when Japan began to rebuild its automotive industry under American occupation, A few of those same engineers found work with newly formed companies Nissan, Toyota, and Isuzu among them. In interviews decades later, they would describe their wartime encounter with the captured Jeep as a turning point in their understanding of engineering. Toyota's early post-war designs, including the Land Cruiser prototype developed in 1951, drew direct inspiration from the Willys Jeep's architecture, a machine built not for beauty or ceremony, but for endurance and universality. When asked years later about that first encounter in Rabaul, an aging Hoshino reportedly said, "We did not just inspect an enemy vehicle, we inspected the future." In the autumn of 1945, as the smoke of war settled across the Pacific, Japan stood amid the wreckage of its own industrial philosophy. Factories lay silent, rail lines twisted by bombing, shipyards empty. The old order of divine craftsmanship, the belief that precision equaled strength, had collapsed along with the empire that preached it. For men like Captain Masao Kitamura and Lieutenant Tadao Hoshino, the surrender was not only a national humiliation but a personal reckoning. They had spent the war convinced that Japan's mechanical skill, inherited from centuries of artisanal tradition, could outmatch the crude abundance of the United States. Instead, they had watched an enemy machine built cheaply, built quickly, built for the many outlast everything they had believed in. When American occupation forces arrived in Tokyo, they brought with them hundreds of jeeps. They were everywhere, crawling over broken roads, ferrying officers through the ruins, delivering mail and medicine to towns that had not seen either in years. To civilians, these vehicles became a symbol of both defeat and possibility. To engineers, they were a reminder of what the war had revealed, that simplicity could be a form of genius. Hoshino was demobilized in 1946 and returned to civilian life in Yokohama. He found work as a technical consultant for a small automotive shop repairing occupation vehicles. His first task was maintaining a fleet of jeeps left behind by the U.S. Army's Quartermaster Corps. For nearly 2 years, he lived surrounded by the same machine that had once shattered his wartime certainties. He learned to rebuild its transmission, to fabricate gaskets from scrap rubber, to weld fractured axles using scavenged steel. The more he worked with it, the more he understood why it had impressed him at Rabaul. Every part had a purpose. Every bolt could be replaced. The design was honest, an engineering humility that was entirely new to him. Kitamura's path was quieter. He returned to Osaka and took a position in the Ministry of Commerce's Vehicle Reconstruction Bureau. There, he joined a committee tasked with studying foreign automotive designs to guide Japan's own post-war manufacturing. Among the first items on their list was the Willys Jeep. The committee's findings would later influence Japan's first generation of post-war utility vehicles, the Toyota BJ, the Mitsubishi PX33, and eventually the Land Cruiser line. Each borrowed lessons from the wartime Jeep: simple frames, standardized parts, and field-repairable systems. But beneath the technical evolution lay something deeper, a psychological reorientation. Before the war, Japanese engineers had treated machines almost as sacred objects, reflections of the craftsman's virtue. After the war, they began to treat them as democratic tools. Machines were no longer to be perfected, they were to be perfected for use. This shift mirrored a broader cultural change sweeping across occupied Japan. American industrial advisors under General Douglas MacArthur's administration encouraged a management philosophy that prioritized efficiency, standardization, and continuous improvement, the seeds of what would later become the famous Kaizen system. Many of the men who had once studied the captured Jeep found themselves at the forefront of this transformation. In 1948, when the Ministry of International Trade and Industry organized a technical mission to study American manufacturing, several former Army engineers, including Kitamura, participated. They toured the Willys plant in Toledo, the same factory whose nameplate he had once traced with his finger in the Rabaul hangar. Standing on that assembly floor, watching rows of workers fit axles and gearboxes in minutes, he understood at last what the war had obscured: that the true power of American engineering lay not in any single invention, but in the system that united design, labor, and production into one continuous process. In his trip report, now archived in the National Diet Library, Kitamura wrote, "What we once saw as weakness, the use of ordinary labourers, interchangeable parts, and loose tolerances, is in fact the foundation of strength. It allows the creation of abundance, which is the real weapon of a modern nation." He returned to Japan with a conviction that would shape the next 40 years of Japanese manufacturing. By the mid-1950s, Toyota and Nissan had begun producing light utility vehicles modelled directly after the Willys. They were exported to Southeast Asia, the Middle East, and Africa, the same regions where the American Jeep had once fought. In a profound historical irony, these Japanese machines, descendants of the very vehicle that once symbolized defeat, would become symbols of Japan's industrial resurgence. Hoshino, by then chief engineer for a subcontractor supplying Toyota, once remarked to a visiting journalist from Asahi Shimbun, "It taught us humility." Every bolt on that vehicle was a lesson in practicality. The war showed us that perfection is not strength, endurance is. By the 1960s, Japan's automotive industry had fully absorbed those lessons. The nation that had entered the war building fragile, hand-fitted machines emerged from its ashes as the master of mass production. Factories once dedicated to aircraft parts now turned out reliable cars for global markets. The echo of the Jeep was everywhere in the modular design of the Datsun pickup, in the rugged simplicity of the first Land Cruiser, even in the philosophy of field service manuals written in plain, accessible language. And through it all, the memory of that first captured vehicle lingered among the men who had once dismantled it on the edge of the Pacific. In 1972, when historians from NHK interviewed surviving Imperial engineers for a documentary on wartime technology, Hoshino was asked what had been the most technically impressive foreign weapon he had seen during the conflict. He smiled faintly before answering, "It was not a tank or an aircraft. It was a small four-wheeled vehicle that could travel 60 miles an hour across the jungle. We studied it not as an enemy's machine, but as a teacher." He paused, then added quietly, "It showed us what we had refused to believe, that democracy could design better machines than hierarchy." The surviving Jeep at Rabaul did not endure much longer. According to Australian occupation records, it was found in a maintenance shed in late 1945, still operational despite years without proper parts. The vehicle was shipped to Sydney for inspection, photographed by Allied intelligence, and eventually scrapped. But among the men who had once examined it, its memory became something almost mythic, a symbol of their own awakening. For them, the Jeep was more than a machine. It was the mirror of an age reflecting both the triumph of practical engineering and the tragedy of ideological blindness. In the quiet years after the war, Kitamura retired from public service and taught mechanical design at Osaka University. His students remembered him as a reserved man who began every lecture with a simple rule: a machine must serve those who use it, not those who build it. Few of his students knew where that rule had come from. He passed away in 1979. Among his papers, his family found a small, rusted nameplate, Willys Overland Motors, Toledo, Ohio. He had kept it since Rabaul. Perhaps he understood that this small artifact, torn from the hood of an enemy vehicle, represented the most valuable lesson the war had ever given him. In the end, the irony of that moment remains one of the quiet truths of the Second World War. An empire that prided itself on the discipline of its craftsmen was humbled by a machine designed to be fixed by any soldier. A culture that believed strength lay in purity learned that survival lay in adaptability. And a generation of Japanese engineers raised in reverence for perfection discovered that the future belonged to imperfection harnessed for purpose. The Jeep, that unassuming box of steel and bolts, taught them that progress is not the art of making flawless things, but of making flawed things work everywhere, for everyone. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.